So today we are going to now jump on to another extensively used design pattern. So you might already know the name, but let's start with a question. We'll rather take a question and then we'll arrive at some extensible solution. And whatever we'll arrive at, that will be the pattern of the day. Okay. Everyone has ordered pizzas from Domino's or Pizza Hut. Everyone has done that at least once, right? I believe all of you did that. Okay. What do you think? Can you estimate the number of varieties of pizza that Domino's offers? Yeah, I would like you guys to take a guess. Just take a guess. You can Google this thing or whatever you want, but give me a number. What, according to you, is the number of varieties of pizza that Domino's serves? 10 to 15. Okay, Shubham says 10 to 15. Anyone else? All of you understood the problem. Is it that you did not understand the problem, so you are not responding to it? Because it's not a tight question. I just asked that, what do you think is the number of varieties of pizza that Domino's offers? So Amanish is saying it's 21. Shubham said it's 10 or 15, 10 to 15. Okay. First of all, there are multiple varieties of pizza that can be served by a pizza outlet. Okay. It can be 10 to 15 also. It can be 100 to 200 also. It depends upon how innovative they are. And why? Why so? Let's try to understand that. Because let's say initially you have a very basic kind of pizza, which is just a thin crust. It's just a thin crust and there is no topping on top of it. Yeah, that is a very basic pizza, healthy pizza. Okay. Now, let's say you add a cheese topping on it. Then it becomes a cheese thin crust pizza. Now, let's say on top of cheese, you add some olive. Then it becomes olive cheese thin crust pizza. On top of that, you add mushroom. Then it becomes mushroom olive cheese thin crust pizza. So this number can just grow. If you have more and more toppings, this number will just grow. Tomorrow, if you have a topping of, let's say, corn, if you have a topping of whatever, a topping of paneer, a topping of anything, then it will just grow with time, right? So just think of it in this manner. The number of varieties of pizza that an outlet or a pizza company can serve, it has got something to do with the number of toppings or the varieties of toppings that they support, isn't it? So let's take a very simple example. Let's say I want to start baking my own pizza. I want to register myself on Swiggy and I want to start selling it. Now, let's say my base is fixed. My base is a thin crust. And then I have three kinds of toppings. So I have mushroom topping, okay? And then I have olive topping, and then I have cheese topping. These are the three kinds of toppings that I have. And my base is fixed. Now, can you tell me the total number of different combinations of pizza that I can serve, given that I have three kinds of toppings? Yeah, let's take a quick guess at that. Somebody's saying 6. Okay, others? 2 part 3, which is 8. That's right. Very basic one, isn't it? Yeah, so it's nothing tricky. It's nothing tricky. So let's look at my screen. So let's say your base is fixed. Base of the pizza is fixed, and that is thin crust. Now your topping could be anything. So you could have a topping of mushroom, you could have a topping of olive, you could have a topping of cheese. Okay. So now I can say that if I want to bake a pizza, then of course I'll start with a thin crust. And on top of this thin crust, if I want, I can either add this mushroom or not add this mushroom. Okay. And then on top of it, I can either add this olive or not add this olive. And then on top of that, I can either add this cheese or not add this cheese. So what does it mean? That for every topping, I've got two choices. Either I can add it or not add it. So 2 into 2 into 2, that is going to be your total number of combination of pizzas that you can bake and sell. Is it making sense that why is it 2 power n if the different number of toppings is n? Yes or no? Anything? That would help me understand if you're able to connect with me on what I'm saying or not. Okay. So basically, the issue over here is that there is an exponential number of varieties that I can have. Exponential number of varieties, right? It is just limitless. Tomorrow I might want to bake thin crust, double mushroom, double olive, single cheese pizza. So when I say double mushroom means there are 2 layers of mushroom. And on top of that, there are 2 layers of olive. And on top of that, there is 1 layer of cheese. Okay, so basically the varieties can be limitless. Now, whenever you have exponential number of varieties like this, then the problem that we basically encounter as a result of that is called as a problem of combinatorial explosion. Because there are different combinations, and you said it's 2 power n, so it's a problem of combinatorial explosion that's happening over here. Now, the real problem with this is that how would you build a software for such a pizza baking company which bakes enormous varieties of pizza? How will you do that? What is the brute force solution for it? So somebody might think that, hey, if you have, let's say, 10 to 15 varieties of pizza, then for every variety, there can be a class. So maybe you can just have a class, which is, let's say you support thin crust, mushroom, olive, pizza. So you can have a class for this. Okay. So there is a dedicated class for a particular variety. Now let's say another variety is thin crust, mushroom, cheese pizza. So you would want to build another class for it. Do you think that this solution is an extensible one? Or in other words, would you personally prefer this solution? Yes or no? No, you won't prefer the solution. Why won't you prefer the solution? You won't prefer this solution because if you do something like this, the number of classes that you would end up building will be infinite, will be 2 power n. Yeah, it's too many classes. There'll be so many classes out there, right? Now, if you are at all wondering that what will be the content of any class, so that also we can discuss. Maybe if, let's say, it's a thin crust mushroom olive pizza, then it'll have a reference to a variable of thin crust, and then it will have a reference to a variable of mushroom, and then it will have a reference to a variable of olive. That's the thing. Okay. So basically every class, depending upon what items it is baked off, it will have reference to that. There is one more problem with this approach, that if, let's say, you have a thin crust double mushroom pizza, there for every item, you will have to store that how many instances of that are there. So you'll have to say that, hey, thin crust, it's base, so there is only one base. There are 2 layers of mushroom, and then there is 1 layer of olive on top of it. So this data also you will have to keep. Moreover, the ordering of this should be such that it tells you that what lies on top of what. Because right now, if I permute it randomly, if let's say I put this olive in between here, then somebody will get an impression that, hey, okay, the base is thin crust, but on top of thin crust, maybe there is an olive, and on top of that, there are 2 mushrooms. So this is not giving a very clear picture of the things, that how is this pizza baked and designed. So there are so many problems. The first problem with this design is that there are too many classes that we will come up with. That problem is technically called as the problem of combinatorial explosion. Okay. The second problem is that there can be a particular topping could have occurred multiple times. So for that, you will also have to specify an integer, a quantity, that, hey, this thing is present these many times. And the next thing is about ordering, that, hey, your variables, they should be ordered in such a way that it somehow tells that, yeah, this is on top of that, that is on top of that. And this cannot be reinforced. I mean, you can't tell your developer that, hey, put order in exactly the way in which the layering has been done. So this is not a good design for sure. The greatest problem over here was of combinatorial explosion, and the other problems that I have told you are also some problems that are hanging around. But does it make sense to all of you? Do you relate to me on why these problems are actually a problem and they need to be addressed? Okay, awesome. So how do you plan to address them? All the design patterns have been inspired from the nature. So people look at the nature, they look at fundamental things, and from there they come up with, oh, we can build something like this and give it such fancy name for the world to feel curious about it. So you just think like a child from the very beginning, from how would you optimize it? Take it as a mathematical problem, take it as a puzzle, and then let's try to solve it. What comes to your mind? Let's think about it. Okay, so Aman is saying we can have a basic pizza class and then a class of toppings. The topping class will have thing like count, order. Okay. So Aman, what I can see over here is that you have a basic pizza class, and let's say your basic pizza class only contains the base, which is the base is thin crust. And now you're saying that there is another class called as topping. Okay. Now, when you say that there is another class called as topping, what kind of class should that be? Should that be a concrete class or should that be an abstract class? What would you prefer? An abstract class. Okay. Anyone else who agrees with what Aman is saying? You know, if you read in between the lines and try to figure out that why he's pointing out to the creation of abstract class, you will realize that whether it is a mushroom or it is an olive or it is a cheese or it is an onion, whatever it is, at the end of the day, these things are topping only. So what I can imagine is that topping can be my super type, abstract type, and then these things can be thought of as its subtypes. So this is one idea that comes to mind. Does other also agree with it? Yes or no? Do you feel that can be done? Okay, cool. Good. Now let's take just one step ahead from here. Okay. What I would say is whether you have a thin crust mushroom olive pizza or whether you have a thin crust double mushroom pizza, at the end of the day, all of them are what? Pizza. Yes. At the end of the day, all of them are nothing but pizza. Think of it in this manner. Let's say you have thin crust mushroom olive pizza. And now you put a topping of, let's say, onion on it. What do you get as a result? Whatever you get as a result is nothing but a pizza only. So we can say that the scenario over here is that we have a pizza which could have contained multiple varieties of toppings. I do not care about that. But when you put another topping on that, what you get is again a pizza. Does this sound like some sort of recursive formulation? It's like recursive formulation, isn't it? Like you have a pizza and then you say you add something on top of it and what you get is again a pizza. It's a different kind of pizza, but at the end of the day, it is pizza. And then you add another thing on top of it. Again, whatever you get is a pizza. I can think of it like a recursion based scenario where my termination case is of base. My termination case is of base. And my base could be thin crust. My base could be a wheat base. It could be anything. I do not care about it. All these bases are also pizza. And all these toppings are also pizza. And when you put a topping on a base, what you get is also pizza. You put another topping, what you get is again a pizza. Everything is pizza. So it can be thought of it in this manner that if somebody asks me that, hey, define pizza mathematically for me, then I would say that pizza is either equals to a base or pizza is equals to pizza, some other pizza, let's call it pizza dash, plus a topping on top of it. You know, this is how you define recursive relations. You say n factorial is equals to n into n minus 1 factorial, and it is equals to 1 if n is 0. So all that I am saying is that you can imagine pizza in this manner, that every base is also a pizza. And if you put some topping on any pizza, what you get is again a pizza only. Is this recursive formulation making some sort of sense to you guys? Yes or no? Yeah, it does. Okay. Now that it makes sense, now we can start thinking a lot of things on top of it. Okay. So let's get going. I'll show my ID. Okay. So I have created an abstract class called as pizza. Okay. And I know that every pizza will have a name and will have a cost. Okay. So there is a constructor which takes in the name and cost and initializes them accordingly. Now there is a getter for name and then there is a getter for cost also. Okay. Now let's say you have a thin crust. So thin crust is a base, but that can extend pizza because that is also a kind of, what is thin crust? Thin crust is also a kind of pizza only. Now, because thin crust is something that extends the pizza, so all the variables that are declared over here, those variables also belong to this thin crust. So whenever somebody tries to initialize thin crust, the first thing you will have to do is you will have to initialize the name and the cost of thin crust. So that is what we are doing. When we are calling super of this and that, then what happens as a consequence of that is that name and cost for thin crust is initialized. Okay, that is what is done. Okay, I'll ask you one simple question. This is constructor of thin crust. Let's say I put a random line here, int x. Then I'm getting some error. Can you tell me why I'm getting this error? It's very weird. I just added a random line, int x. Okay, so Aman is saying that super needs to be called first. Can you see this? A warning on my screen. It says that call to super must be first statement in constructor body. Why is it so? Can somebody tell me why is it so that Java does not allow me to write anything before invoking the constructor of parent class? What can be the logical reason behind it? There has to be a very strong reason behind it, right? Otherwise, people would just be surprised that, hey, what is this? So what do you think? Type it in the chat box. Okay. So let me tell you, the reason is very simple. When you initialize thin crust, because thin crust extends pizza, it means that an object of thin crust will have name field and cost field, right? Now, if in your first line, you try doing something like this dot get cost or this dot get name, what will happen? Abrupt behavior, because you are trying to get the cost of something without initializing the cost for that. Or you are trying to get the name of something without initializing the name of that. If you were allowed to do anything here, you might have done something like this also. And if you would have done something like this, then you would have probably gotten garbage values of cost and name and all because you have not initialized them. So the first hard and fast requirement is to invoke the constructor of the parent in order to initialize those data members. Is it making sense? How many of you get the reason behind it, that why it's absolutely mandatory to first call super and initialize those fields? Make sense? Yeah, cool. So anyways, this does not have anything to do with design, but this is something that you should know. So you can see that I have a thin crust which extends pizza, and for thin crust I have passed that this is the name and this is the cost. Similarly, there is another kind of base, let's say wheat base. So for wheat base also, as you can see, I have passed the name and the cost. Okay. Now, let's talk about the toppings. For me, all toppings are also pizza only. Okay. But when I think of any topping, then that topping is basically put on top of what? The topping is put on top of some pizza, right? So let's say I'm talking about a very simple topping, let's say cheese topping. So, when I have created a cheese class, I have made sure that it extends pizza. Why? Because for me, every topping is a pizza. And now it has a field inside it, and that field is a pizza. Do you see what I'm trying to say? Because you put cheese on some pizza. So it can be thought of as this cheese is wrapped around this random pizza. And this pizza could be literally any kind of pizza. It could be olive, onion, thin crust pizza. It could be something like that. But I don't care what that is because I only know about the abstract type, the abstract pizza. I just know about the abstract pizza. Okay. And now this cheese is put on top of it. Now, if you remember those methods, those very simple methods like get name and get cost. Let's talk about get cost. If you want to implement get cost, how do you think it should be implemented? So when you put cheese on top of a pizza, then what should be the new cost? The new cost should be the cost of previous pizza plus the cost of cheese. So you can get the cost of cheese by calling the parent get cost method, which is present inside the pizza method, which will actually return the cost that is of cheese. So if you do something like this, what is this line doing? This line is actually going to return 9, which is the cost of cheese plus the cost of the underlying pizza on top of which you put that cheese. So what we are doing is we are decorating this pizza with cheese on top of it. That's why this is called as decorator pattern. Technically, we are decorating an object with something to get something which has the same type. So you are decorating a pizza with cheese, and what you get is again a pizza only. Do you get the point? How many of you are able to follow me so far on this? Okay. I have done same thing for a name also. So if let's say you have wheat base onion pizza, and now you put cheese on top of it, then the name becomes wheat base onion cheese pizza. So when you do super dot get name, then the name of this cheese, it will be appended to the name of underlying pizza. What problem is this design solving? Anyone who would like to answer what problem this design is trying to solve? Do you realize that going by this design, I do not need to create specific classes for specific pizza? Let's take a very simple example. Let's say somebody wants a wheat-based cheese pizza. In the brute force approach, you would have gone on and created a new class called as wheat-based cheese pizza. But here, I don't need to do anything like this. You know what I'll do here? I'll just, let's say, create a dummy class just to give an example. Static void main. Okay. Now, let's say I want to create a wheat-based cheese pizza. I'm writing it here. Wheat-based cheese pizza. So I know that I can create a wheat base by invoking this constructor. Okay. So I'll call new of wheat base. Okay. Now, what is this? Can you tell me the type of this? Come on. What is the type of this object? The type of this object is a pizza, right? Yes. So can this object that I just created, can it be passed inside this cheese class? I mean, can I send it to the constructor of cheese? Yes, I can. So can I do something like new of cheese, and inside the constructor of this cheese, put this thing. As a consequence of that, whatever I have gotten is a wheat-based cheese pizza. And now what is the type of this? Tell me. Tell me what is the type of this? The type of this is also a pizza, because every cheese is also a pizza. So now can I put a topping of mushroom on it? Tell me. Yes, so I can do new of mushroom, and I can send this entire thing inside. So what do I have now? Now I have a wheat-based cheese mushroom pizza. Okay, can I put another layer of cheese on top of it? Yes, because this entire thing is a pizza, and this can be sent inside the constructor of this cheese. So I can do new of cheese, and inside it, that entire huge thing can be sent. Do you see it now that now no longer I need to create multiple classes for every variety? Is it making some sense, at least 40–50% sense to everyone else, that what is the problem that we have solved? Yeah. So when we started off with brute force solution, we said that for every variety, there will be a new class. But now you do not need it. Okay, now you do not need it. Now, what is this entire thing? What is the type of this entire thing? Tell me. Pizza only. This entire thing is a pizza only. Now, given that, what is the cost of wheat base? The cost of wheat base is 1 unit. And what is the cost of cheese? The cost of cheese is 9 unit. And mushroom is also 1 unit. So can you tell me what should be the cost of this pizza that I have just created? Cheese costs me 9 unit, and mushroom and wheat base costs me 1 unit. So what should be the cost of this pizza? Should be 20 rupees, isn't it? Okay, let's check that out. Println. If I do p dot get cost, what should be printed ideally? Everyone is convinced it should be 20, right? Because cheese costs 9, so 9 plus 9 is 18, and mushroom costs 1, 18 plus 1 is 19. Wheat base also costs 1, so it should be 20, and that is exactly what you have gotten. And this you have gotten because of the nature of code that you wrote here. All that you are doing is you are adding your cost on the top of the cost of underlying pizza. Does this statement make much more sense now? What is it doing? Whatever it is doing, yes or no? Yeah, okay. The same thing you can do with name also. You can say system dot out dot println p dot get name. I mean, naming convention is up to me whether I go from bottom to top or top to bottom in pizza. At naming convention, I can decide. So if I run this, so the name that I get is cheese, mushroom, cheese, wheat based pizza. And it is technically correct. There is nothing wrong with it. Okay. Does this make sense? Okay. So this is how it works. Now, do you see one very beautiful thing over here? The beautiful thing is that imagine that there is a class which has a function inside it. And that function takes pizza p as an argument and does something with that pizza. Probably gets the cost or gets the name. Now that function does not have to care about different varieties of pizza. It can simply invoke p dot get cost, p dot get name, and get everything that is internal to it. So that is the beauty of abstracting thing. That is the beauty of having super types in your system. Because now what will happen is that such a function will not be worried if in future you go ahead and create new toppings or new bases. Do you see my point? Okay. There is a question. We should all try to answer that. I want you guys to answer Shant's question. So Shant's question is, one thing is not clear to me, when exactly we have to use this pattern. Yeah, who wants to answer it? So when do you think you might want to use this pattern? Tell me. Like in state pattern, when we had state-based systems, we used to use it. Like for which kind of problems would you want to use this? Something like this. Do not say just for baking pizzas, because this was just a very simple childish example that I wanted to give for the clarity of concept. All the other topping classes like mushroom also, if you see, it has the same implementation. It encapsulates a pizza. Mushroom is put on top of pizza, and implementation of this and that is the same as the case with olive. So yeah, so Shubham is saying when we have to handle exponential combination of entities. Very good. So whenever that is the case, it happens. Another thing, whenever you get a feel of it, that you are decorating entities or you are decorating objects, then this is a beautiful pattern. I'll give you a very simple example. How many of you have ever dealt with front-end development? Anyone who ever wrote any code in JavaScript or React or Angular or Vue or anything? A lot of you? Okay, awesome, great. So have you ever encountered that you build a front-end component and then you put another component on top of it? And then you put another component on top of it. So it's like, let's say you build a carousel. Now you wrap that carousel around something else. And then you wrap that around something else. And then you wrap that around something else. Do you see what I'm saying? How many of you are getting a feel of? Those of you who are front-end developers and have coded it, I'm pretty sure you'll get a feel of it. What is that? That is decorator pattern in action. So if you look into the official React library, which Facebook engineers have implemented, they have used decorator pattern. They must have used something like that. I've not read it, but it's a classical case of uses of decorator pattern. So whenever you feel like there is an object which can be wrapped with something, and what we get belongs to the same super type, that is a classical case of decorator pattern. These examples, do they make sense to everyone, wherever? So there is one curious question. Why not just mention all of the toppings as a list and apply for functions such as cost, etc. by doing a loop? That's a very good question. I'll answer that. For now, when you look at this thing, this is decorator pattern for you, ended. Now, when you read code written by some very gray-haired engineers who have taken care, who have honored the design patterns. Like usually when you see the code written by principal engineers or very senior people in like good companies, including FANG ones, you will see that they take care of design patterns. And sometimes looking at the code, you can figure out that what is the underlying design pattern that might be there. I mean, see, what I'm trying to say is, if I just look at this main function, and if I see this line, I'll get a feel inside it that, hey, somewhere in the code base, decorator pattern is there. Why? Because if you are writing anything like new, then new, then new, so if you're doing a lot of nested news, then that's a symptom of the fact that you have decorator pattern deeply buried inside your code base. Because what is it? If you are doing new on top of new, new on top of new, new on top of new, it means that somewhere you are decorating object on top of another to get the same type and all. Are you able to connect to me? Like what I'm intending to say? I'm not sure if I'm making some sense, but you guys can let me know if that helps. Yeah. Yeah. So if you ever encounter a code like that, you'll get a feel of it, that decorator pattern is deeply buried somewhere inside the code base. And trust me, even if you did not know about decorator pattern until today, you have used it. You have been using it. Trust me. Anyone who'd like to tell me where you might have used it? Are you aware of something like buffered reader? Anyone who is aware of this class, buffered reader? What is it? It is basically used to read the data if you want to read something from file. Now, do you want to take a look at this buffered reader class? So this is official Java class of buffered reader. Buffered reader, the constructor takes a reader. The constructor takes a reader. And the type of this buffered reader, I mean the super type of that, is also a reader. Isn't it just like pizza? Can you relate to it? Yes or no? So, do you know, if I come back to my main function, inside buffered reader, I can pass some other kind of reader, let's say file reader. File reader is also a kind of reader. Buffered reader is also a kind of reader. This entire thing is a kind of reader. The mechanism to read data has been intensively simplified by making use of decorator pattern. It's a beautiful, I would say the most beautiful application of decorator pattern internally in Java. See, when I simply say file reader, what is the feel that you get? What do you think this object might be doing? This object might be containing some methods that would allow us to read some text from a file which is stored on our hard disk drive, isn't it? That is the feel that all of you would be getting, right? Now, whenever you read some text from hard disk, then that is costly. That takes you some time. So let's say you are reading line by line. So you go to hard disk and then you fetch, that hard disk moves that pointer, what is that called? Head that points to some sectors, and then you read the data. And then again, you go to the next line and then you read. So that entire process, it's mechanical. It takes a lot of time, basically. Now, this can be improved. So let's say you have a while loop, and in that while loop, you are running that while loop for 1,000 iterations. And in each iteration, you are basically reading the next line from your file, which is on hard drive. Now, it can be improved. How it can be improved? When you call read method for the first time, maybe what we can do is, instead of reading just one line, we can read next 10 lines and store those 10 lines inside the RAM, so that the next call will not have to now go to the hard disk. The next call will be entertained from the RAM only. So what you are doing is you are creating buffer of the data that you have read from hard disk drive. So this is what buffered reader does. Without disturbing the job of file reader, what buffered reader does is it simply creates a buffer of data on top of it. Are you able to connect me on this? So whenever you write some piece of code like new of buffered reader and then inject inside it some other form of reader, this is what it does. So now, if you talk about this thing, this is a reader. On this reader, if you invoke a dot read method, it will not read line by line. What it will do is, when the first call to read is made, instead of reading just one line from the hard disk, it will read 10 lines, probably 10 or 15 lines, depending upon how much buffer space we have in our RAM, and then store all those things inside the RAM. And then it will also return you the first line that was there. Now, when you invoke dot read inside your while loop for the second time, then instead of going back to the hard drive, it will return you the data from buffer. And now again, when you call dot read, it will return you the data from buffer. The only optimization that it is doing is it has a buffer. So let's say your mom tells you that, hey, I'm sitting here on chair, go to the kitchen and bring some potatoes. So she tells you, go and bring one potato. You'll go bring one potato. Go bring another potato. You'll again go bring another potato. Go bring another potato. Again, you will do same thing. Better is when you go for the first time, bring 20 potatoes. That's in your buffer. And then entertain your mom with those potatoes. And next time, again, when you go, again, fill your buffer. That is what this buffered reader does. It's just an optimization. Now that optimization is provided on top of the functionalities of file reader. Is it making sense? Yes or no? Yeah. And the user of it gets no clue about what is happening internally. So you might be using, have you created a reader like this, new of buffered reader, and inside it you might have created new of input stream reader, and inside it another new and all. Have you? I'm pretty sure you would have created, and you would have blindly called read method on that object without even knowing what complex things are happening internally. So this is the beauty of decorator pattern, that without disturbing the behavior of this reader, it puts another reader on top of it. Yeah. So feels useful, feels like a very useful pattern. When I read, does it feel to you like a very useful pattern? I mean, if I say honestly, when I read it for the first time, to me, it felt like a very, very useful pattern. And I have actually applied it at multiple places in my work. How many of you have written SQL queries? They're like something from something where age greater than 9 and sex equals to male and something else. After where whatever you have is some sort of filter, right? If I want you to write a system, an extensible system that allows me to filter the data, can you do that? So this is a question that one of our students who is currently in low-level design course, he was interviewing with a company called Nutanix. It's a very good company. He was asked this question. So I'll tell you the nature of question, how it was. The nature of the question was like this. So you are given a class called as result. Just look at this class. So it basically denotes the mark sheet of a student. Okay, it denotes the mark sheet of a student, and there is a map which contains a result field and string. What is result field? Result field is physics marks, chemistry marks, maths marks, and then age of the student and gender of the student. Okay. So that is all present inside this thing. And the marks are basically currently stored in form of string. Okay. Age can also be stored in form of string, and gender can also be stored in form of string. This is the constructor, and this is a get method. So whenever you do get for a field, and let's say the field is physics marks, then you will get the marks that that student got. So that is what this result class is all about. Does everyone understand what this class is all about? This is basically like a record. Okay, nothing else. Now, what we want is, we want to build a system that allows us to filter a list of results. So I'll tell you what is my expectation. My expectation is that you guys build something. I'm just calling it something right now. This something should take a list of records or list of results. Okay. And then it should apply some filter on top of it. Let's say I say that, hey, I have the results of 100 students. Now I want to filter those students whose physics marks is greater than 90, whose age is greater than 15, and sex is equals to female. Then I should be able to do that. So the input is also a list of results, and the output is also a list of results. Common sense, isn't it? This is what I want to build. So this kind of filter is what I want. This was the interview question. Is it making sense to everyone? Yes or no? That what it is that we want? Immediately, the first thing that comes to mind is that, hey, probably I'll go ahead and write an interface or an abstract type called as filter. It'll have a filter method whose input is a list of filters, whose input is a list of results, and output is also a list of results. Okay. Now, can you think ahead from this? Can you think that how you can build an extensible system on top of it? Okay, let me give you some more hint. Maybe what I can do is I can write a specific implementation of filter called as equal filter. Equal filter, what it does is that it takes a list of results and iterates on it. And only those results whose this field is equals to this value will be filtered out. Do you see my point? Let's say there is a mark sheet in which a student got 100 marks in physics, another student got 60 marks in physics. And now my requirement is that physics mark should be greater than 75. So only the person who got 100 mark will be filtered out. So there is an equal filter and I can implement it very easily. All that I have to do is, if I want to implement it, I'll simply iterate on all my filters. I would say for result R in my results, I'll say that if R dot get field, this field, if R dot get field is exactly equals to dot equals the value. If it is equals to this value, then this is something that I want to shortlist. Okay. So I can create another list. I can say this is what my shortlist is. And if I see this condition is true, then inside this shortlist, I'll just go ahead and add that R. Now, by the time this loop is over, by the time this for loop is over, it is obvious that all the members of this list who would have passed this test would have been fed inside this. So I can just return it from here. Shortlist. So this is just an implementation of equal filter. Similarly, you can probably think of writing another class. You can call that class as greater than filter. So what greater than filter will do is that it will compare whether the value that is there is that greater than the given value or not. Similarly, you can have a smaller than filter. So there are different implementations of this filter that you can write. And all of them are filters only. So that is one thing. Is it making sense to everyone that how I have implemented equal filter? What does this method do? And how you can go ahead and probably create a greater than filter and smaller than filter. Think of it? Okay. Now, an important thing over here is that we want to support and or conditions also. We want to support and or conditions also. So we might want to build a new filter called as and filter. You say no that I want to get those records which obey condition 1 and also obey condition 2, right? This is what you say. The same thing will be there for or filter also. So and filter is a kind of filter only for me. So this will implement the filter interface. And because it implements the filter interface, it will have to implement that filter method. Now tell me, what should be the instance variables of and filter? Can I say and filter works on top of two filters, filter 1 and filter 2? Yes or no? Just think about it. Whatever is the result of filter 1 and whatever is the result of filter 2, you just take their AND. What is the meaning of taking AND? Intersection. Do you know how to take intersection of two arrays or two lists? Yes, it's a DS algo problem. You can do that. So the two inputs to it will be filter 1 and filter 2. So the first input is private final filter 1, and the second input is filter 2. Okay, these are the two inputs. Now they can be passed around in the constructor. Do you realize one thing, that the implementation of AND filter does not care about what are the types of these two filters, whether they are equal to filter or not equal to filter, or they are greater than filter, smaller than filter, or they are some another AND filter only, or some OR filter. They don't care about it. All that they do is they'll say that, okay, let me invoke filter 1 dot filter for this results. From here, I'll get my first list. I'll call it list 1. Similarly, I'll get list 2 by invoking filter method of filter 2. Now the core logic will come. That core logic is to basically find intersection. Intersection of what? Intersection of list 1 and list 2. List 2. So this is how your AND filter is implemented. What is this? Can I say this AND filter is decorated on top of two different filters? Can I say that? Come on. Yes. Similarly, can you write OR filter also? Yes. OR filter will also do the same thing, but here it will now will it find intersection? What is OR? What is the mathematical term for OR? Union. Yeah. So now you will have the logic too. So do you see the beauty? The beauty is that this filter contains the logic of its core logic only. It does not care about how greater than conditions are taken care of, how equal to filter works and all. And now you can, just create multiple filters. Who knows that first filter itself was another AND filter only. Somebody might have said that, hey, the first filter that I have is something like condition A and condition B. And the second filter that I have is condition C or condition D. But I'm able to do everything so beautifully because at the end of the day, this entire thing is of type filter. And that entire thing is also of type filter. And this entire thing is also of type filter. So it can also be passed around to some other AND filter. Yeah. Okay, cool. So there is a homework for you guys. When you go back, try implementing this thing on your own. Just write some AND filter or filter and then create those and just pass your data around and see whether this is working as expected or not. Okay. It will break for something like and. Like and. What do you mean by and? Why will it break for something like that? It's not necessary. I mean, if you pass things around easily, I'm just writing it in the chat box. I believe you're talking about something like A and B and C. I don't think it will, because if you have something like this, it does not matter how you put your brackets. I mean, A and B could be your filter 1 and C could be your filter 2. Or B and C can be your filter 2 and A can be your filter 1. It does not matter. Certain places, it can matter. Like when you say, when you write conditions like x greater than 5 and y greater than 2 or z smaller than 6, here the placement of brackets matter. Now, going by the placement of brackets, you have to create your object. Do you see what I'm saying? It's an important thing to be kept in mind. So I'll just give a quick example of what I just said. So let's say you have something like, you're saying x greater than 5 and y equals to 9 or z equals to 3. Now here the placement of brackets will impact the output of result. So if you put a bracket here and here and another bracket here and here, let's say this is one placement. The result of this can be different than the result of something like this. Let's say you have a bracket here and another bracket here. So the way you put your bracket, it will impact your result. First of all, do you all agree that? Yes or no? Do you think that the output of this can be different than the output of the previous way in which I had put brackets? Yeah. So when you create your object, you have to create it in that manner only. Like what I mean by that is, because here you are taking you're taking and of these two things. So your outermost filter, it will be an and filter. Okay. Your outermost thing will be an and filter. And inside it, the first item will be greater than filter, and second item will be or filter. But let's say if the nature of bracket was different, let's say the nature of bracket was something like this. You had first bracket closing here and another bracket starting here. In that case, you are taking or of two things. So in that case, your outermost bracket would have been or filter. And inside, do you see the point? How many of you see the point? What I'm trying to say? So yeah, basically, depending upon how you place your brackets, you'll have to construct the object accordingly. But the beautiful thing is that the constructed object is a filter, and just a simple dot filter invocation on that object will do everything beautifully for you. Okay. Somebody asked a question that why don't we have a list of decorated objects just at one place? I'll try to answer that question tomorrow. That'll take some time for you guys to consume it. There's a question, if the filter 1 and filter 2 passed inside constructor, if the filter 1 and filter 2 passed inside constructor are also and filtered, there is nothing stopping user from doing this, right? No problem. Any object that implements filter interface can be passed. I don't care what that object is, whether it is and filter or it is or filter or it is XOR filter. I don't care. All that I care is that object must implement filter interface, because if it implements filter interface, it is guaranteed that it will implement filter method. And all that I have to do is I have to call filter method. That's it. Okay, cool. So great then. So we have covered 3 design patterns: strategy and state and decorator. So 3 are done, only 2 are remaining. So this is the time when you should go back and probably reflect. I want you guys to do this exercise today. Okay, I'll take it seriously for sure. Like just take the learning of these 3 days, go into an introspection mode and figure out or list down your key learnings. See, this subject is different than DSA. Okay, so after class reflection is very important. You know, people say that you don't learn design in one day, in one night. You don't learn design in a week or so. Why? Because we don't usually have this habit of reflecting upon whatever we have learned. If you reflect, you can learn it quickly. That has worked for me, and I trust that will work for you. So when you go back, reflect upon your learnings of the last 3 design patterns and write it in points on the chat in your WhatsApp group. So mention that, yeah, these are the 5 key takeaways of the design patterns that I have learned in these 3 days. And I'll add on to it. I'll give my feedback on top of it, that maybe you can take this thing like that. Let's do this exercise. Okay. And then you will see that have you achieved some delta in these 3 days or not? That will give me also some sort of good feeling in terms of whether I was able to bring in some delta or not. Although we have 2 more classes to go through. But yeah, if you reflect, I think it will be great. Yeah. Okay, then cool. So let's meet again tomorrow and continue from there. So bye, everyone.